In this video, we will be looking at frictional force. So frictional force is a force that opposes the motion of the object, and it always acts parallel to the surface of the object. The units of measurement for frictional force is newtons. We have two types of frictional force. We have the static frictional force, which is the frictional force when the object is standing still on the surface. And then we also have the kinetic frictional force, which is the frictional force when the object moves or slides over a surface. And we have this statement, which is very important. So here we are saying for an object to move, the maximum static frictional force should be less than the applied force. And we have two equations that are very important here. We have the maximum static frictional force equation, which is this one here. So the maximum static frictional force is equal to the coefficient of static friction multiplied by the normal force. Then we also have the kinetic frictional force, which is equal to the coefficient of kinetic friction multiplied by the normal force. Moving on now to an example here. So in this example, we are having a 15 kg box that is resting on a surface. And for A, they're saying John begins to push this box with a force of 10 newtons to the right. And they're asking whether this box will move or not. Okay. So now, for us to be able to answer this question, we need to firstly get the maximum static friction. So the equation for maximum static friction is this one. So we have the coefficient of static friction multiplied by the normal force. In this scenario that we are having here, so if I were to draw the free body diagram, the forces that we are having here, we are having, especially the vertical forces, we have the normal force, and we also have the weight of the object. Okay. Now, because we're only having these two forces vertically, it means they are balanced, right? Meaning that normal force is equal to weight. So in this scenario, our normal force is equal to our Fg. So to calculate the normal force, we'll say it is equal to Fg, and Fg we know it is equal to mg. So normal force is equal to, the mass is 15, acceleration due to gravity is 9.8. So 15 times 9.8, that is 147 newtons. So this is our normal force. Now we're going to take this normal force that we got here. So this is the normal force, and substitute it into our maximum static friction equation. So now to calculate our maximum static friction, it will be the coefficient of static friction multiplied by the normal force. We have our coefficient of static friction, which is 0.35, multiplied by our normal force, which is 147. So the maximum static frictional force is 51.45 newtons, right? And if we were to go back to our notes and read here, for an object to move, the maximum static frictional force should be less than the applied force. And in this case, our maximum static frictional force is greater than our force applied, because our force applied is 10 newtons, remember, and our maximum static frictional force is 51. So because the maximum static frictional force is greater than the force applied, then the object will not move. Object will not move. Okay. Now moving on to B. And before I go to B, I think I need to erase maybe here. I'll just erase this. So for B, they're saying, what is the frictional force and acceleration exerted on the box as John pushes the box with a force of 10 newtons to the right? Okay. Now to answer this question, remember we said the box is not going to move because the maximum static friction is greater than the applied force, right? So the object is not going to move, meaning that the acceleration is 0 meters per second squared. Okay. So we have already answered this part for the acceleration. Now we need to answer this part for the frictional force, right? So if I were to draw this box here, so this is the box, we have the surface, and this box, it is pushed to the right by John, right? Now this box is not moving because the forces are balanced, so meaning that the force applied is equal to the frictional force. So force applied is equal to the frictional force, and as a result the box is not moving, right? So the frictional force here is basically equal to force applied. Okay, so frictional force is equal to also 10 newtons, and that is it for B. And then moving on to C. For C, they say, what is the acceleration of the system if John pushes the box with a force of 90 newtons and the coefficient of kinetic friction is 0.2? So now if you check properly, now the force applied, which is that 90 newtons, is greater than our static friction, because remember our static friction that we got was, I think, 51 point. Let me write it down here. Our static friction was 51.45 newtons. So I want you to notice something. Now this maximum static frictional force is less than the force applied, and therefore as a result now the box will move now, right? Because our force applied is greater than the maximum static friction. Okay, so now they want to know what is the acceleration of the system if John pushes the box with the force of 90 newtons, and now they also gave us the coefficient of kinetic friction. So now they gave us the coefficient of kinetic friction because the box now is moving. So now to determine this acceleration, remember we have this equation. F net is equal to ma. And what we are looking for here, we are looking for acceleration, right? So now, in this case, I'm going to draw the box, and John is pushing this box with the force of 90 now. Okay. And obviously, as John is pushing this force by 90 newtons, there's going to be friction, right? There's going to be kinetic friction because now the box is moving. But now we need to calculate this kinetic friction because we don't know it. So kinetic frictional force is equal to the coefficient of kinetic friction multiplied by the normal force. The coefficient of kinetic friction in this case is 0.2. And then the normal force, we did calculate it. There's this one here, which is 147. So 147. And the coefficient of kinetic friction in this case will be, let me just punch it here on my calculator. So it's 0.2 times 147, which is 29.4 newton. Our kinetic frictional force. So now our kinetic frictional force which is the force that opposes the motion of the object as it is moving, it is 29.4 newtons. And the force applied is 90 newtons, right? Now to get F net, remember F net will be the force applied minus the frictional force, which is the kinetic frictional force in this case. And then the force applied will be 90 minus the kinetic frictional force will be 19.4. Then 90 minus 29.4. So 90 minus 29.4, that is 60.6 newtons, right? Then I'm going to take this F net that I got here and substitute it into my equation. So F net equal to MA, and then my F net is 60.6 equal to the mass is 15 kg. Acceleration, we don't know. Divide by 15 both sides. 15 cancels with 15, and therefore acceleration is, so 60.6 divided by 15, that is 4.04 meters per second squared. This is our acceleration. So that is it for this question here. See you guys on my next video. Thank you.